Welcome to this tutorial on Darlington Gospel, and in this tutorial I'm going to show you how to create your first smart contract with Solidity, and you're going to see me live teach one of my students how to do this thing step by step with no step missing. Okay, this is what I'm going to have you do, for you to be part of this tutorial. I would like you to visit the Remix ID, okay, on the internet. That is, you go to remix.id.com. Let me just show you there. So on the Remix ID, all you just need to do is to go to this contract folder and then right click on it, create a new file and call it, for example, demo. So but what we'll be using for this tutorial is actually donors.solidity, and then you click enter. I've already created this, so I don't want, like, right now I'm having a duplicate of it, so I don't want a duplicate of it. So but this is how you do it, and this is where you should be writing all the codes that we'll be doing for this particular tutorial. And once you finish writing it, I'm going to come back and show you how to test it with the Remix ID. You're going to see how it works live. Okay, so you ready? All right, let's get started. For that, make sure you hit that like button, subscribe, okay, and hit that notification bell, because you don't want to miss any of the tutorials that are being released on this channel. Super important. If you want to be a Web3 developer, you got to be part of this channel, because I'm releasing constantly tutorials that will help you, that will usher you into the Web3 space. So with that said, let's get started. So now this is the environment, and I'm going to share this link to I'm going to share the GitHub repository to you, so that that is what you use in kickstarting your smart contract development. So basically what you just need to understand here is this thing called this folder called contract, and in the SRC folder, go to the contract folder, and there I'm going to create a new file, and you will see it right there. It's going to call donors.so. Can you see that? Is it reflecting? Yeah, open that file so that you'll be on the same page with me. So donors.sol is the extension for a Solidity file. All right, so just like every other programming language, all the files that they use in coding them have their own extension. So .sol is the extension for Solidity smart contract. So now the first thing you want to know is that to create your first smart contract, you should always have this information about a license identifiers in Solidity. They are used to lay claims on digital properties, and your smart contract is a digital property. So there are some predefined or already existing smart contract, that is smart contract or digital licenses, and one of them is MIT. So we're going to be using that MIT to label our smart contracts under that license, so that anybody that is using our smart contract, we have to use it around the boundaries of MIT, right? So how you do that is by saying put /, you use SPDX dash license, right, dash identifier. Anyway, you don't understand, you let me know. Say MIT, right? This is the first thing you need to write whenever you're creating a Solidity file. Okay. Secondly, the next thing that you need to do is to define to give information of the kind of compiler version that Solidity is given to compile this code. So compilation is necessary when you want to transform your high-level language, these codes that you're writing in an English-like format, into a machine executable version. What translates your code to that version is called a compiler. And these compilers, they have different versions, just like softwares, they have different versions. So what I'm going to show you now is how to define a compiler within a range of compiler that are authorized to compile this, that can compile this smart contract successfully. So this is how you write it. Say pragma, right? And then you say solidity, and you specify the version that is anything greater than or equal to 0.7.0. So compilers within the range of 0.7.0 down to what? Compilers that are in the range of 0.9.0, and end every solidity line. Every line of code in solidity must end with a semicolon. Hope you understand that. Okay, fantastic. So this is how you will specify the kind of compilers that we go ahead and compile your smart contract after you're done with it. So now the next thing now is to define the structure of the smart contract. Basically, you know, if you've done something like object-oriented programming, we have something like class, and in that class we have the class name, and then we have the block that surrounds every code that will be written in that particular class. So smart contract follows similar pattern, but in this case of Solidity and smart contract, they actually change the name class to what? Contract. So you start by what? Contract. Okay, this is a keyword for declaring a contract in Solidity. And then you say donor, which is the name of this smart contract. And then what? A block of code. This block of code, this is where you do all your coding. All the smart contract logic are going to what? Going into this particular location. You getting that, right? All right, so fantastic. So now let's go to the next thing. The next thing you need to know about creating this smart contract. Note here, we're trying to achieve people. This is a crowdfunding smart contract where people all over the world can make donations to us. All right. So for us to receive donations from people, we need a smart contract that will serve as an intermediary for doing that, and then we can integrate it to a DApp, like a decentralized application using front-end frameworks such as React, the React Native or Next.js to put that together and make it like a website so people can make donation with their Ethereum wallet. All right. So first thing, we want to be able to capture every payment that people donate. Like I want to be able to we want to be able to keep track of how many times each person donates to us, and how much in total that person has donated to us. So we want to keep track of these things so that everybody kind of have like an account with us, and we'll be able to keep track of people that are making donations to us, and in case in the future we have gifts for them, we can quickly reference that and contact them using their wallet ID. Hope you get this logic right here. All right, so how you make all this sort of architecture or record keeping is through a Solidity variable called mapping. Okay, mappings. This is how you declare. You say mapping. All right, and then in that mapping you open a parenthesis, and then I want to map every addresses. All right. So remember, address in Solidity, symbolizes a person or a smart contract. So every user or a smart contract on the Ethereum network has an address. That is how I send money to you, and you send money to me. That is how you send money to a smart contract, and you receive money from a smart contract. So addresses are like emails or like a bank account. Understand? It represents a person. It holds a person's current balance, and has information about all the transactions that this person has performed in the network. Get that? So for every individual that interact with our smart contract, that is by contributing to our smart contract or to this donor smart contract. What will happen? We want to keep track of what is the number of times that he has donated, which is using this uint basically. I want to say it is public. Okay, uint is called an unsigned integer. That means an integer. Integers are what? Numbers that don't have decimal places. That will range from negative 100 to positive 100 and so on infinitely. Okay, so but what you want to do is to what? Make sure that you only want the positive ones, positive integers. We don't want minus this, that, and that. We just want all the way positive. So that's why we're using uint. So this uint is a variable type in Solidity that only holds what? Positive integers. Did you get that? All right, go on. Yeah. So the concept goes like this: for every person that makes donation in a smart contract, this is like an associative array in PHP. Just think about it like that. So the address is the key, and the amount that this person is paying is the value. Okay, so the address of this person will whenever I enter the address of this person, it's going to give me the amount that he has contributed. That is what you are seeing by this address, this arrow pointing to what, uint. That is pointing to his money. Okay, the money that he has contributed to us. Yeah. So, and then this, now this public is what is called access specifier. It specifies the kind of accessibility you can have, to this particular variable that we are creating. Okay, so if it is private, for example, like this, you can't access it. You that is outside of the smart contract is only things within the smart contract body that can have access to it. But we want people outside to be able to have access to what? Information regarding how many times they have made payments to us and all that. So we want to make it public. And then lastly, you give it a name. This is the name of this variable that we just created, and the name of the variable is called payment of. Okay, and every line of Solidity with what? A semicolon. You understand? Okay, so now we want to create something similar to what we just done now. But this one, the first one, we hold, information like the total number of times, the total number of money that each person that donates into our platform has made. Then this second one I want to create, we hold the total number of times that this person has made. For example, you could have made up to like $1,000 to this donation, to this smart contract, right? But you didn't make other payments one time. So I want to keep track, like, okay, you made this payment that augmented up to what? To $1,000. You made it about 6 times. So this next one, we hold information about the number of times that you actually made this donation. All right. So, all right. It's a variable. Yeah. Just think about it like a variable for an array. A variable name for an array. Yeah. So let me duplicate this one, and this one, the same setup, but I'm just going to change the name. The name is going to be donations by. Okay, so it will hold information about the donations by a certain individual. Okay, donation by every single individual. That is what it's going to hold. So the same setup. So now the next thing I want to define is a different kind of variable. This variable is going to hold the information about the creator or the deployer of this smart contract. Note, if you did PHP or any kind of programming languages such as that, there is this thing called different data type. We have integer, we have float, we have characters, that is strings, and all those sort of things. Solidity has that too, but there is a certain data type called address. Okay, so which holds addresses only. It doesn't hold any kind of thing. It's not an Ethereum address, it's gonna reject it. So I want to create an address data type. This is how you start it. And this address data type is going to be payable. Payable means that it can receive money and it can send money. You understand this thing? Okay. And then the access specifier, I want this to be public. All right. So this public. So this variable is going to be seen by all. And the name of this variable is called owner. So end with semicolon. So basically it's going to be an owner variable. It's going to hold information about the person that deployed this smart contract to the network. Okay. So now this next one is also uint. So it's an unsigned integer. So it's going to hold only positive integers. And this is going to be public, of course. And we call this one balance. So basically, this is going to hold the total amount of money that has been sent into our smart contract, this donor that have been donated to us. Total. That is total contribution of everybody that has ever made contribution to our smart contract. Do you understand that? Okay. Now, the next thing I want to do is to create another variable. This one, I'm going to call it withdrawn. Withdrawn. I'm going to explain what it will hold. Withdrawn is going to keep track of how many times that, going to keep track of how much that we have withdrawn so far from this smart contract, because we as a charity foundation, and we are receiving money from people, so we want to also withdraw this money and then put it into good use, right? So we want to keep track of how much so far we have withdrawn from this smart contract, so that this variable will take note of that. Okay. All right. So now the next thing I want to do is want to keep track of the overall total donations in our smart contract, which is, I'll call this one total donations. Okay. This one is different from this one. This one is keeping track of the total money that has been withdrawn. This one is keeping track of the total times money has been withdrawn. So for example, if I withdraw about $5,000 from this smart contract, I could withdraw this $5,000 over six times of withdrawal. You understand what I mean? Hello? Yeah. So now this total donation is going to keep track of the total number of times that you've done withdrawals on this smart contract, and then lastly, I'm going to have total withdrawals. Okay, which is going to keep track of the total number of time I've withdrawn money from this smart contract. So that is just what it does. This one keeps total number of times that donations have been made to us. This one keeps total number of times withdrawals have been executed from this smart contract. All right. Okay, so the next thing that I want to create an event. What is an event? An event is a piece of log. It's more like logging something, to the console, logging extra information about a certain thing that just occurred on your smart contract. For example, whenever a person, donates to us, that is an event. There is a donation that just happened. We want to log out some extra information on the console, okay, so that it will be there, on the EVM, so basically it's just me voicing out some special information that just happened on this smart contract. That is what it is. So how you create an event is if you say the keyword event, and then you give the name of the event. Let's call it donation, and then you open a parenthesis. Take note, everything is in Solidity ends with a semicolon. Yeah, except for blocks such as this. You understand this one? This one doesn't have to end with semicolon, but this always have to end with semicolon. So inside of this, I'm going to define the content of this event, like the kind of information this event should emit whenever a donation is made to us. First of all, I want to give this an ID. What does it mean? Like, okay, this is the first donation, donation number 2, donation number 3, donation number 4, all those kind of things. I want to keep track of what the donation ID. I want to keep track of this is an address data type. So, and this is to. So this to is a variable basically. And what does it mean? It means that I'm just going to remove it. Let me change it to from. Okay, so this from is going to keep track of whom is making this donation to us. So the address of the person that is making this donation to us is called what? From. You understand? Yeah. So like for example, like if you donated to us, so this money is coming from you. So I want to keep track of that information that it actually came from you. All right, and then there is this keyword called indexed. In an event, this indexed helps us in doing some further filtration process. Let's say we are using it, or we want to research or want to check this thing on. There's a place called Ethereum Explorer. So it's more like a place where you find all track records of everybody's accounts, everybody's activities on the blockchain, because the blockchain is public. So there's nothing really hidden there. So you can check all these things using. So this index makes filtering out information a lot easier. It's more like in your MySQL database when you have a keyword, an indexed column that helps in what? Sorting out data faster. All right, so the next thing I want to keep is what? I want to keep track of the amount that was what? Donated to us. And lastly, I want to keep track of the time, like the timestamp, like the particular time this donation was made to us. You get that? All right, so now that is how you create an event in Solidity. Okay, and we can create two. Let's create another one. Okay, let's create another one called withdraw, so that this one we want to change the name withdraw. Okay, so this one we fire withdrawal whenever we withdraw money from what? A smart contract. You understand that? Why this one we fire whenever donations are made to what? Our smart contract. Okay. Alright, so the only difference between these two is that I'm going to change this from to this into to, so that it will what? Tell me where this money was withdrawn to. Okay? Yeah. Why this one is telling me where this money came from? Why this one is saying where this money went to? Okay? All right. So now the next thing you need to know is about the constructor. In object-oriented programming languages, constructor is an inbuilt function that is first triggered before any other thing is executed inside of that smart contract. So for example, whenever I instantiate this smart contract, or when I deploy it to the network, this particular function will be the first function to run before any other thing will start being executed on the platform. You understand that? So how you create it is what? A constructor. See that? And then, all right, and then you say parentheses, and then you open a block, and this is where you write any logic, any set of things that you want to what? To execute first before this smart contract become accessible to anybody. So for example, we can, this is like a function, but it's not a custom function. This is an inbuilt function, and you can pass parameters inside of this, but we're not passing any parameters inside of it now. So what we just want to do is to say this owner, this owner variable. You see this owner variable created here, this one. You understand? So we are saying now that owner okay, we want to define who the owner is whenever we deploy the smart contract. To define who the owner is, okay, there is a global variable in PHP. It is called super global. Okay, so a global variable called MSG. It contains information about whomever deploy this smart contract to the web, or whomever sent money to us and all those. So how you get the person that sent this smart contract to the network is by saying msg.sender. All right, you understand? msg.sender is, it's the person that will deploy the smart contract. So we just save it as as the owner of the smart contract. Okay. All right. So now to make this person, because remember here we said that the owner is payable, right? Is payable. You can see this, right? So in order to make this thing work without the compiler giving us error, we got to make sure that this person that is the msg.sender is also payable. So to do that, we just need to surround it with this payable clause here. All right, like a function, and just put it inside of it. You get that? All right, great. So the next thing I want to create a function called donate. This function now will be responsible for receiving money from people. Okay, so how you create a function in Solidity is by saying function, using the keyword function, and then you give the name of the function. The name of this function is called donate. Okay, you see that? Now for a function to receive money, you have to also put that keyword called payable. You understand that? If it doesn't have this keyword payable, it can't accept money from people. Okay, so we have to put that keyword payable, and then we want to make it public, because this is the only way that people can actually interact with it outside of the smart contract, so that they can receive money. If it's not public, its purpose has been defeated. So now this is how you write it, and then you open a curly brace. Now the first thing I want to do, want to make sure that people are not sending us 0 ethers. Some people can be very funny, so they will like to try your smart contract and do some things that could break it. So for example, they will want to send money, like empty money to us. Okay, we don't want to receive 0 naira or $0 or 0 ethers, but everything in the Ethereum space is represented with ethers. So don't mind that I'm using dollars and nairas, because those keywords are a lot easier for you to comprehend. But we don't want zeros whenever we are receiving money. We want something that is greater than it. So for us to make sure that is the case, that is obeyed, that law is obeyed, we want to set it as a law, and we want to make sure that it is required. So we use this keyword, this inbuilt function called require. Okay, and then in this parenthesis here, we have to supply what we want to require. We want to require that MSG is a global variable, remember, and this value contains information about the amount of money that was sent to us. So the amount of money that was sent to us will be captured in this MSG.value. Are you following me? All right, fantastic. So we want to make sure that this money that this person is sending us is greater than 0. Otherwise, if it's not greater than 0, we want to give him this notification. We want to tell him that donation, and that is insufficient insufficient payment, or insufficient amount. All right, so I want to say, man, insufficient amount, man, we don't want 0. Okay, so end with semicolon. So this will protect our smart contract from receiving 0 ethers. Okay, the next thing you need to do is to say, now I want to keep track of some records. So I want to keep record keeping by making sure that this person, okay, the payments of these persons are kept, and then the donation of this person are also kept. So I'm going to say payment of what? This sender, this person that is making donations to us, that is MSG sender. Okay, I want to what? Increment. This is an increment plus equal to what? Whatever I have. If I have like 10 ethers before, I want to add that with the amount of money that has been donated more and add it together. So I'm just incrementing it, okay, by MSG.value. Then you say, so whatever the person sent to us, we're going to what? Add it to his account. That is what we're just doing here. Okay? All right, and then for the next thing that we need to do, we want to make sure that the donations by this particular sender, MSG.sender, is also incremented by 1. Okay, you understand this thing? So if this was the second time that he's donating, this thing will increase by 1, and that becomes 2. Keep on increasing like that as many times as he donate to us. Okay, now I want to also increase the store balance, like the general that is the accumulative money that we've received. We want to also keep track of that in this variable called balance. So I want to say MSG.value. Okay, note this one keeps track for a single individual. Meanwhile, this one keeps track for what? The entire money that we are receiving from every individual in our platform. Do you understand that? Okay, and then lastly, for this, I want to say total donation. Okay, we can do this like this, plus equal to what? 1. Okay, we can do this like this. Okay, this is fine. But we can also make it simple and easier by just saying plus plus. Okay, so it will increment it by 1. It means the same thing. Okay, so this also means that I could just say here, I could also say plus plus here too. You get it too? All right, fantastic. So now I want to emit an event. I want to tell the world that a donation has been made in our platform. So I'll do that by what? Emitting what? A donation, that event. So remember, in this place we use the keyword event. Okay, when we were what? When we were let me copy this back. When we were creating the event structure, we use event like this, but this time around, if we want to emit it, we change this keyword to what? Emit. Okay. All right, and then we say this donation, which is the same name. All right, and we are not going to define the data types anymore. We're just going to give it value now. So, for example, the value I want to give to this is called total what? Donation. Okay. By default, this total donation is 0, but the first time that it increment to what? 1. So this thing is now 1. So when I'm putting it here, is actually what? 1. So the ID of this first person that donated will be what? 1. Okay? Yeah. And then the from is whomever is donating to us, which is what? MSG.sender. Yeah, fantastic. I like that you're following. All right, and then the amount that is being donated to us is what? MSG.value. Okay, and then to get the timestamp, okay, is actually clock.what? Timestamp. Clock is another that is global variable again that you must take note of. Clock keep track of essential information about a certain block that this our transaction, because what we are creating is actually a transaction. Whenever somebody sends money to another person, it's called what? A transaction. So a block contains what? Series of what? Transactions. So, for example, each block we have information of the current timestamp that a transaction took place. Okay. So now this block, we are saying dot timestamp, it will get us the current timestamp. All right. So we are done for this particular function. Okay. Now the next function I want to create is called what? Withdraw function. Okay. This is the last function for today. We want to call it the withdraw function. So say function, right? Withdraw like that, and want to give it name. So want to specify the amount of money I want to withdraw. Okay, so you specify it. This is how you pass parameters, no argument into what? Parameters in Solidity functions. Okay, so you specify the data type too that you want to pass as a parameter, which is what? An unsigned integer. And this unsigned integer is actually the amount of money that I want to withdraw. Okay. And then it should be public. Okay. And I want to show you this new keyword, say returns. All right. Take note that this thing is not called return, it's called returns. So it's specifying the kind of what? Data type that this function will return after it is done executing. Do you understand that? Okay, and I want it to return Boolean. All right, Boolean, that is true or false. I want to be able to tell if this function executed fully or not. So that's why I'm saying what? Returns bool. Do you understand that? And I'm going to supply that information later. So now I open a block right here, and I want to set some certain parameter. For example, I don't want people, even though this is public, I don't want anybody to just be able to come here and just withdraw money from us, right? We don't want that, right? We want only the owner, okay? The owner of this smart contract, like the charity foundation, to be the one that has the authority, the clearance to come and what? Withdraw money from this smart contract. Do you understand it now? Yeah, so I'm going to say require that what? This msg.sender, that is the person that is trying to withdraw money from us, okay, is actually the what? The owner. That is, it's equal to what? The owner. Okay? So if it's not the owner, I want it to what? To scream out and say unauthorized personnel. You understand that? And end with what? A semicolon. So if you're not the owner of this smart contract, you can't withdraw money from what? This smart contract. So on our requirement, I want to put it there. I want to make sure that we have enough money that, like, we have the kind of money that you want to withdraw from us. So for example, if we have 5 ethers and you want to withdraw 10 ethers, we want this smart contract to tell you that it's insufficient balance. So the amount of money that you want to withdraw we must have possession of that money before you withdraw it. Okay? So we say require that the balance, okay, is greater than the amount that you want to what? Greater or equal to the amount that you want to withdraw. So otherwise, tell you what? Insufficient balance. You understand that? Just like what an ATM will tell you if you are trying to withdraw money that is more than what you have in your balance. Okay? Go on. So the balance should be greater than the amount that you want to withdraw, or at least you should have equal amount of balance to the amount that you want to withdraw. For example, if I want to withdraw 5 ethers and then in my balance I have 5 ethers, this thing should go through. Okay? Yeah, that is what it means. Okay. So now the next thing that you want to do now is now to make sure that you you recalibrate the balance so that the balance will be showing the right available balance after the withdrawal. So I want to say this balance, I want to minus, okay, I want to remove the amount that was withdrawn. Okay, that is what I'm doing right now. The balance minus the amount that was withdrawn. Okay, and I want to increment this. There's what we call withdrawn. We have this variable called withdrawn here. Okay, that keeps track of the total amount of money that was withdrawn from our platform. So I want to say withdrawn, want to increment it like, okay, we've withdrawn this amount. Okay, so it will not keep track of the volume of amount or the amount of money, the volume of cash that we've withdrawn from our smart contract. Okay, so and now we also want to keep another. So we want to actually execute. Want to say this thing. Want to say total withdrawals. Okay, increment it like. Sorry, total withdrawal, not total donate. Total withdrawal. Okay, so with total withdrawal, I want to increment it by 1. Okay, so this is the first time we withdraw, so it will be 1. Withdraw again, it will be 2. Withdraw again, it will be 3. Understand that? And then lastly, we want to send the money actually to that address, to the owner. I want to cash out. Okay, so cash out, you say owner, this particular owner, and then we call dot transfer. Okay, now we are transferring the amount of money. All right, and that amount of money will now go to what this particular owner. So the charity foundation can now withdraw the amount that they specified here parameter, right? And once that is completed, I want to emit an event again. This time is the withdrawal event. Okay, so I want to emit this event called what? Withdrawal. And remember again, you change this keyword to what? Emit. All right, yeah. So now they want the emit to be what? The ID to be what? The total what? Withdrawal. Okay, and then this tool is like the address that the money was going to, and you know that the money was going to this owner, right? Yeah, and the owner is the same thing as what? The MSG dot what? Sender, because it's the one that has the ability to what? Even access this function. Do you understand this? No, we can just leave it like this. Okay, to be the owner. Okay, so let's just leave it like this to be the owner to ease in your understanding. All right, and now with the amount of money, of course, this is the amount that you actually cashed out, and then the time that you made that withdrawal is, you say what? Block dot what? This timestamp. You understand that? And then lastly, because I made this statement called returns book, I want to return a certain what? This is like an indication that the entire function ran, so it was executed successfully. So I say return. This time I'm not saying returns, I'm not using S, I'm only saying return. Okay, so that is the difference between this one and this one here. So I say return true. So that means what? Executed what? Successfully. You understand that? So at this point now we can save our smart contract because we finished all the coding that has to do, right? And now let us test it out and see what is going on with it. Right? You ready? So it's time to do some testing. So I want to take this time to personally test this smart contract to show you how it is working on the Remix ID itself on the website. So you just need to visit remix.ethereum.org, and once you're there, you come to this contract place and you create a new, right click to create a new contract, call it donors.so. Solidity. Now you paste the entire code. You can just copy it and paste. You compile this donor. After compilation, you deploy it. Fantastic. We use this first account to actually deploy it. So before we click on that deploy, this one was a default selected one. Now we have the deployed contract down below here, and the balance is currently 0, as you can see, 0 ether, but here too we have 0 ethers as well. Fantastic. So the next thing that you need to do, let's test out the donation process. So for example, let me choose a second account here, and I'm trying to donate with 0 ether. I want to change this denomination to ether. So I'm trying to donate with 0 ether. If I'm trying to donate with 0 ether, then I click donate, it's going to respond with what? Insufficient amount. That is because here we've already given a law that if somebody is sending money that is not at least greater than 0, it should not what? Accept. Okay, so that's what happened there. So for this donate function to really accept your money, you have to specify some ethers. So for a first donation, let's send 2 ethers in there, and then we click on donate, and you see that it works, showing a good check mark. And you can see here I have 2 ethers in this balance, and when I click on this one too, you have 2 ethers here. This is a representation of ethers in WIG, which is a smaller denomination of that Ethereum native currency. Okay, so now let's check, let's donate again a second time. So this second time, let's donate like 1 ether more, or let's say 2 ethers more, and let's click on this donate. It went well successfully, and when we check our balance, we have 4 ethers now. And now this total donations is 2 because it's only made by 1 person. And now let's come here, choose a second individual. Okay, make a donation of 3 ether, and let's click on donate. It went well successfully, and the balance now is 7 ethers. So now let's check the donations of this person, this current person. Donations by this person, when we check, is 1. You see that he only donated 1, and his payment, the payment that he has made to us, is just 3 ethers. Fantastic. Okay, because this smart contract is keeping track of the donations made by each and every individual that contributes to our donor smart contract. So let's check the second person. We copy his address, and you come all the way here, enter the total number of donations. So you see that this person has made 2 donations, and when we click here and paste, see that he made 4 ethers. He sent 4 ethers to us in that 2 donations that he made, and the total number of donations in the smart contract is 3 now. Okay, so now the donation thing works great. Now let's try doing some withdrawal. Okay, so in making some withdrawal, let's try to use an account that is not the owner. The owner is the first one. Let's use the second one, and let's try to withdraw. Let's say 2 ethers, because we have 7. Let's withdraw 2 ethers, and let's click on withdraw. It fails with what? Unauthorized personnel, because we programmatically encoded this law here that if the person that wants to withdraw is not the owner, let it fail with this error, unauthorized personnel. So now let's just say now we are choosing the authorized personnel, which is the owner. The owner ends with what? EDDC4, and if I come here and click on this owner, you see that it ends with what? EDDC4 as well. So now what you need to do, let's say for example we specified a higher amount of money than we had in the smart contract. We had 7 in total, but let's try withdrawing 9 ethers. You click on that, it says insufficient balance. Now it's no longer complaining of what? Unauthorized personnel. So that is because we're withdrawing more than we have, and it can't go that way. So you remove it. Let's withdraw something like 5 ethers. Now I want you to look at the amount of money the owner has right now, so which is 99.99 ethers. So now when we click on this withdraw, it went successfully. Now check that you see that the money of the owner increased. That is because of the withdrawal thing that is going on under the hood. We sent, because of this function, this owner.transfer sent the amount from the smart contract, which once had 7 ethers, it sent 5 ethers out of it, remaining 2. Now if we check our balance, we also have 2. And if we check the total number of withdrawals we've made is what? Is 1, and the total number of money withdrawn is 5 ethers. Let's say I come here and I'm withdrawing, half an ether, okay, and I click on withdraw. When successfully check, this is how much, 5.5 ethers that we withdraw. Total number of withdrawal is 2. Okay, so this is how the donation function works in Solidity. So I hope this was clear and crystal easy for you and you understand. If you have gotten value from this teaching, please smash that subscribe button, smash the like button, and share. I'm going to hit you in the next class. There are many of these cool feature things that we're bringing in smart contract development, we're bringing in DApp development with React, Next.js, and React Native. They are all coming. NFT Mint, NFT Marketplace, DAO systems. We're bringing in, crowdfunding systems and many other kinds of systems. Even an e-commerce shop on Web3 only, it's coming. So you better hit that subscribe button and watch out. All right. With that said, I'm going to hit you up in the next class. Bye bye.